Hello everyone, so today we're going to go over section 2.3, combining transformations. So far, the three transformations we have looked at, translations, reflections, and stretches, can be combined into this form right here. Y equals to A times F, B, and then X minus C plus D. A is for vertical stretches, B is for horizontal stretches, C is for horizontal translations, and D is for vertical translations. Notice that if B is less than 0, then there's also a horizontal reflection. Likewise, if A is less than 0, then there's a vertical reflection as well. In general, if a function is listed in the format inside of the red box, then we'll consider the transformation in the following order: shape, so stretches; orientation, so reflections; and finally position, which is to do with translations. So another way to thinking about those three types of transformations. Okay, so let's look at some examples. Example 1, describe the transformation of the graph each function would undergo. So in order to do that, we have a base function. In the case of example 1a, that will be y equals to the absolute value of x. And in the second example here, the base function would be y equals to the square root of x. Okay. Now, what we'll do is factor out the 3 from inside of the absolute value. So we have 3 times x plus 2, like so. And now we can describe what the transformations were. So there's a 3, which means they're a horizontal stretch by 1/3, followed by the plus 2, which means the function moves left 2 spaces. Likewise, for example 1b, we'll factor out the negative sign. So we have negative and then in parentheses x minus 5. And this will all be underneath the square root sign. Okay. Something like this. So the two transformations will be, number 1, a reflection over the y-axis, and number 2, move the function 5 spaces to the right. Okay. So next we will graph some of these. Sorry about the color choices here. Y equals to the absolute value of x. Okay, that's a simple fix. All right, so now we have examples 2 and 3 where we actually graph the functions. Start with example 2. We're going to use the graph of y equals to the absolute value of x, so drawing in light red here, to graph y plus 2 equals to negative and then absolute values 1/3 x minus 4/3. All right, so just like the previous example, we will factor out the 1/3 from inside of the absolute values, and that will leave us with x minus 4. And now, of course, the absolute values. There we go. And then minus 2 from both sides. So now there are 4 transformations that happen. It's kind of moving from left to right. Here's 1, 2, 3, and 4. Okay, let's look at what each one is doing. Number 1, the negative sign is a reflection over the x-axis. So the graph will be upside down. Number 2, there is the 1/3, which means there's a horizontal stretch by 3. The third transformation is the -4, x minus 4, which means the graph moves right 4 spaces. And finally, the fourth transformation, -2, so down 2 spaces. Okay, so one way to graph the transform graph or the image is to start with some points that we know. So let's say, for example, -2, 2, and just transform the points through each of the 4 transformations in this case. So the first transformation, reflect over the, oops, I didn't write what axis it was. Of course, this would be the x-axis. That's better. All right, so this would become -2 and -2. And then the next transformation, horizontal stretch by 3. So this would be -6, -2. Third transformation, right 4. So +4 on the x-coordinate. So -2, -2. And finally down 2 spaces. So it will be -2, -4. It's the location of, let's say if the original point was called A, then this would be A prime, will be -2, -4. So let's go ahead and plot that. Here it is. Oh, sorry, that's not -2, -4, that's -4, -2. Let's try that again. There we go. Okay, let's look at another point. Let's go with 2, 2. So, reflection, that would be 2, -2. And then the horizontal stretch will give us 6, -2. Going to move the graph to the right 4 spaces, so that will give us 10, -2. And finally down 2 spaces, and this will become 10, -4. So it'll be over here. And something to note, we have one more point, 0, 0, and that's all we really need to graph the image. So 0, 0. What's interesting about 0, 0 is that if we have reflection or stretches, and that is when we multiply the x or y coordinates, since the x and y coordinate are both 0, it doesn't actually do anything. So it still be 0, 0 after the first 2 transformations. Right, so this would be still 0, 0. This would still be 0, 0. And now the translation will actually move it to the right 4, so this would be 4, 0. And then down 2 spaces, so 4, -2. Okay, so 4, -2, there it is. And now we'll draw straight lines to connect the points that we have. 1 and 2. Alright, so that's the graph that we will end up with. Okay, be nice to label some of the points as well. So here we have -2, -4. This is 4, -2. And finally 10, -4. Alrighty, let's look at the domain and range of the transform function only. So since it is still an absolute value function, the domain x is an element of the real numbers. Range, as we can see, y is less than or equal to -2. Alright, let's look at the example number 3, which has to do with a square root function. The square root function y equals square root of x is transformed to y plus 1 and then 2 times the square root of -x plus 3. Right, so similar to the previous example, let's reorganize things slightly. We have y is equal to 2, and then we're going to factor out the negative sign underneath the square root sign, like so. Alright, and then something like this. And outside of the square root sign, we have -1 from both sides. And now we can look at the transformation. Just like in the previous example, going from left to right, there's transformation 1, 2, 3, and 4. Alright, so transformation number 1, vertical stretch by 2. Transformation number 2, reflect over the y-axis. Transformation number 3, right 3 spaces. And transformation number 4, down 1 space. Okay. So now what? Now what we can do... that doesn't work. Okay, that's okay. Is to look at the original square root function. So it has 0.001142 and 93. And see what happens when we transform them. So once again, the reflections and the vertical stretch will not do anything to 0, 0. So it's going to be moved to the right 3 spaces and down 1. So 0, 0 will now be at 3, -1. So that's the first point. I'm just going to write here 3, -1. Next point, 1, 1. So vertical stretch by 2 will give us 1, 2. And then the reflection will give us -1, 2. Right 3 will give us 2, 2. And then finally down 1 will give us 2, 1. Probably better to write this down like we did in example 2, but to save a bit of time, we have the next point here, 2, 1. So right here. And the next point, similarly, going from 4, 2, after the 4 transformation, will give us -1, 3. And finally, the last point on the graph would be, let's see here, right, -6 and then 5. Okay, just to make sure, I'm just going to check the work on the last point there. 9, 3, so vertical stretch will be 9, 6. Reflect over the y-axis will be -9, 6. Right 3 will give us -6, 6, and then down 1, -6, 5. Alright, that's good. So, of course, we're going to connect these 4 points and draw a curve. Let's see how this goes. It's always tricky to draw a square root function. Hopefully this works. Just do your best to connect the points. So something like, oh, that's not even close. Maybe something like this. Yeah, that's good enough. So that's the function that we have. So it makes sense because the point at the origin moved right 3 and down 1 as it should. And then the resulting graph is twice as tall, and also it is facing the left instead of the right. Okay. Now, to look at the domain and range of the resulting graph, notice that x is less than or equal to 3, and that y is greater than or equal to -1. Okay. So that's the first part. How we can look at some functions and then transform them using A, B, C, and D for stretches, reflections, and translations. Okay, next up we have some kind of generic function, just f of x, and we're looking at what the transformations are. All right, so let's start with the first one. Here. So we have a negative sign, a 2, and a +5 on the left-hand side. Maybe better to color code this. Let's try it. Okay, color number 2 and color number 3. So 1, 2, and 3. So the first transformation, the negative sign, will be a reflection over the x-axis. Next up is the 2. The 2 is a vertical stretch by 2. And the tricky +5 on the left-hand side of the function y +5, if we move it to the right-hand side, that will be -5, so this is down 5 spaces. Okay. Next up, let's see here, we have a 3, and then a -4, and that's it. So the 3 horizontal stretch by 1/3, not 3. We need to be careful there. And then the -4 means right 4 spaces. Okay, next up, just 2 transformation once again. We have 1/2 and then a +7. The 1/2 is a vertical stretch by 1/2. +7 just means left 7 in this case. Okay, last example also only has 2 transformation, 1/3, and then the -2. So this would be a horizontal stretch by 3, followed by up 2 spaces. Okay. So after that, I'm just going to look at a couple more graphs. Okay. Once again, we just have the absolute value function. It doesn't say that's what it is, but that's what it is. All right. Oh, number of transformations. So again, it's best to identify the transformations. There are 1, 2, 3, 4, and 5. Ooh, there's a bunch. So here is the negative sign is the first one, and then the 1/2. There is a 2, which is conveniently factored out already, so that's good. There's a +1, and there's also a -3 here. So transformation number 1, that's a reflection over the x-axis. Second transformation is the 1/2, vertical stretch by 1/2. Okay, after that, there's a 2, which means there's a horizontal stretch also by 1/2. And then the last 2 transformations, number 4, this is left 1 space, and number 5, okay, this is a long list, up 3. All right, so a good way of looking at the transform graph is to look at some key points. So we'll start with 0, 0. Now, recall that 0, 0 is, or the origin is unaffected by reflections or stretches. So we'll just skip straight to the translation. So this will take us to 0, sorry, not 0, -1, 0. And then up 3 will be -1, +3. Okay, so there we are. Let's look at the next point. Let's try 2, 2. Reflect over the x-axis. That would take us to 2, negative 2. Vertical stretch by 1/2, so that would be 2, negative 1. Horizontal stretch by 1/2, so 1, negative 1. This is not lined up very well, but hopefully we get the idea. Oh, this just needs to be a bit lower. There we go. 1, negative 1. Left 1, so 0, negative 1. And up 3, so 0, positive 2. Okay, so 0, 2. Is that right? That doesn't look right. Vertical stretch by 1/2. Okay. Right, okay, so that works. Okay, so let's look at just one more point. Maybe just even negative 2, 2. Very similar, so negative 2, negative 2, negative 2, negative 1, negative 1, negative 1 after the horizontal stretch. And then left 1 will take us to negative 2, negative 1. And finally, the last transformation up 3 spaces will take us to negative 2, 2. Okay, so here we are. All right. So this is right where the graph changes direction. You can draw the absolute function going this way. Oops, that is not it. Okay, let's try that again. That's a bit better. There we go. Okay, let's look at the domain range of this thing. So the domain would be x is an element of the real numbers, and the range simply y is less than or equal to 3. Right. Next one is very similar, so it's going to provide the transform points. Not going to go step by step for this one, just because I can see the video is running a little bit long on time. So after the transformations, these are the 3 points. So negative 4, negative 1, negative 3, 2, and also negative 5, 2. Just like the previous example, let's just connect the points here to make a graph. Okay, that is sufficient. The other side as well, there we go. All right, so let's look at the domain range of this thing. The domain, again, x is an element of the real numbers, and then, whoa, that is not a good, that's better. And then y is greater than or equal to negative 1. Okay, so leave it for later to work out what the transformations are and how the graph end up that way. Moving on. So some quick examples, kind of the reverse of what we did. We have y equals f of x, and then a bunch of transformation that needs to happen, and what is the resultant function. Okay. So y equals, and then it is reflected in the x-axis and has been horizontally stretched by a factor of 6 and translated 7 units down. So we're going to have negative f of x because of the reflection. The x will be replaced by 1 over 6x because of the horizontal stretch, and 7 units down, so minus 7. So that will be the result. Next up, absolute value, y equals the absolute value of x, reflected in the y-axis, stretched vertically by a factor of 1/2 3 units to the right. Okay, this one's a little bit more complex, but we'll see. Y is equal to, and then the absolute value of negative x, that's the first transformation, vertically stretched by a factor of 1/2. So y is equal to 1/2, and then the absolute value of negative x. And finally, 3 units to the right. So x will be replaced by x minus 3. So finally, y equals 1/2 the absolute value of negative x minus 3. Like so. Okay, one more. Let's see here. We have y equals to x squared is reflected into the x-axis, sorry. Stretched horizontally by a factor of 3, and then translated so that vertex is 10, 4. So that means right 10, up 4. Okay, so I guess we can handle it just like we did in example B. So y is equal to negative x squared after the first transformation, reflect in the x-axis. And then after that, stretch horizontally by a factor of 3. So we're going to replace x with 1/3 x. So this will be 1/3 x and then all squared. And then after that, right 10 spaces. So that means we replace x with x minus 10. And of course, up 4, so plus 4. Now, this could be expanded slightly. Just like the previous example, actually, we could expand the parentheses inside of the absolute value signs. So this would be absolute value of negative x plus 3 in the previous example. Makes it look a little bit simpler. Likewise here, we can square some of the terms, not all of them, just makes it look very complicated. So 1/3 squares 1/9, and then we'll leave it as x minus 10 all squared plus 4. Okay, so this is a little bit simpler. And let's see, what else do we have? Right, so again, just listing transformations. 3 examples in a row. Oh, this is a typo. We never fixed this. This was supposed to be y minus 3. At any rate, if we were to look at the transformation that happens here, it's a little bit more complicated. So if we multiply it out, this would be 10 over x plus 1, and then plus 3. So the 10 is multiplied, so that will be a vertical stretch by 10, because 2 times 5 is 10. The x plus 1 means the graph moves left 1. And finally, the plus 3 means the graph moves up 3 spaces. Okay. Next up, in example B. So it's probably easier to, once again, move some things around, -2, and then the absolute value of 3, and then in parentheses x minus 4, and then outside of the absolute value, minus 6. Okay, so let's start with the negative sign. That will be a reflection over the x-axis. Followed by the 2, which is a vertical stretch by 2. And then the 3, which is a horizontal stretch by 1/3. and then the x minus 4 moves the graph right 4 spaces, and finally the minus 6 down 6 spaces. All right, last one. Well, the good news is most of this is already factored out, so we just need to list transformation, starting with the 1/4, so vertical stretch by 1/4. And then there's a reflection over the y-axis. And then there is a horizontal stretch by 1/2, not 2. Let's be careful with that. And then left 3, and then up 1. Again, if we were to graph these, we should look at the shape first, then the orientation, then the position. That means when we apply the transformation to the individual points on these graphs, we should start with the stretches and reflections, and then afterwards we look at the translations. Okay. Oh, wait, did I make a mistake? Oh, wait, why did I write 4? I meant to write 1 here. That's what it was. Sorry about that. That didn't make any sense. So here's up 1. And I think that's it for today. And so thank you for listening.